This is video number 2 for section 11.3, the distance formula. We are continuing our march toward finding the equation of a circle in the xy plane. We started with the Pythagorean theorem, and now we move on to what is called the distance formula. This really comes from the last example in the last video. Remember, we were given 2 points in the xy plane, 2 specific points, and we tried to find the distance between them, and we managed to do that using the Pythagorean theorem. Well, what we're going to do now is we're going to generalize that process. We're going to say perhaps we can just come up with a formula that will tell us the distance between any 2 points. So I've drawn a very general picture here. Let me label my 2 points in a very general way. So I'm going to call this first point x1 comma y1, meaning the first x and the first y, and I'll call the other point x2 comma y2. So this is very, very generic. I'm interested now in trying to find the distance between these 2 points. Well, let's take the same approach that we did before. I don't really have any way to measure diagonal distance, but I can measure horizontal distance between these 2 points, as well as vertical distance between these 2 points. I can't really count spaces this time, but I can use the fact that for the horizontal distance, I'm starting at x1, I'm ending at x2, therefore this distance can be found by simply subtracting those 2 numbers, and you can compare that to that last example. In other words, this horizontal distance is just x2 minus x1. And in a similar way, I can't count spaces for the y distance, for the vertical distance, but clearly if I ended up at a y value of y2 and I started at a y value of y1, that distance, once again, is just the difference between those 2 values. Again, you can compare to the last problem where we subtracted y values in order to figure out that distance. Well, just like before, I've created myself a little right triangle here, which means the Pythagorean theorem applies. The square of the hypotenuse, the c squared, will be equal to the sum of the squares of each leg. Since I'm interested in finding d, I'm going to write the Pythagorean theorem backwards. Let me start with the c squared. So c squared, in other words d squared, is equal to each leg squared and then the 2 pieces added together. Right? I have c squared equals a squared plus b squared. Well, all I have to do to get d is square root both sides to wipe out this squared. Now you may be eyeing this right-hand side, wondering what we're going to do. Unfortunately, there's not a thing that I can do. There are no rules for simplifying square roots of addition problems. You can often simplify square roots of multiplication problems, but not addition problems, and so the right hand of this thing stays exactly as we have it. What we've just come up with is what is called the distance formula. And it really automates this whole process. There's never really a need to draw these pictures again or count spaces or measure spaces. Now we have a formula that simply tells us, look, if you want to find the distance, plug in the coordinates of your 2 points, work out the math, and you'll be all set. Let's try that. We're just being given a couple of points here. And the directions are find the distance between the 2 points. These are just xy points. So I've got my first x and my first y, and then I've got my second x and my second y. I just need to plug that information right into this formula, and out will come the distance between those 2 points. Of course, you could draw a picture if you were a visual person and draw in the triangle and use the Pythagorean theorem, but now that we have the formula, that's a bit overkill. All right, I've got this giant square root. I open up a parentheses. I put in my second x minus my first x. Watch all the signs there. And I square that. And then I put in my second y minus my first y. I have to square that as well. Again, watch out for all the minus signs. In terms of simplifying this thing, you've got these parentheses that need to be worked out. So let's see, 1 take away -3, those guys would plus out, right? That makes 4 squared. And then it looks like the other guy makes -5 squared. Make sure you're following order of operations. The next step would be the exponents. 16 plus 25. And then 16 plus 25 is equal to 41. And so I end up with my distance between these 2 points being the square root of 41. If all I'm interested in is the exact answer, I think I'm done. 41 is a prime number. That you certainly can't break it up into a good radical or a bad radical. Just pay attention to the directions. If they desire an approximation, of course you could go to the calculator. I got about 6.4. Again, all we're saying is that if you were to draw a picture of these 2 points and connect the dots with a straight line, the distance of that segment you drew would be about 6.4 units. That's the distance formula. Well, that's the tool, the final tool that we need to help us to come up with the equation of a circle, and that's where we will head in the next video.